This is section 1.6, equations involving absolute value. So the absolute value of any real number, which we use this symbol here to denote the absolute value, is just the distance that that number inside the absolute value symbol is from the origin on the number line. So remember, our origin is 0 on the number line. So if I had the absolute value of, let's say, -2, here's -2 on the number line, which is 2 units from the origin. But similarly, the absolute value of 2, which is right here on the number line, is also 2 units, is equal to 2 units from the origin. So the absolute value of any number is always the positive, because distance is always going to be positive. So absolute value is always positive. So when you're solving an equation that includes the absolute value, your first step is always going to be to isolate the absolute value expression onto one side of the equation. Once you've done that, you need to set that absolute value, what's inside the absolute value symbol, equal to both the positive and the negative of the opposite side of the equation. Next, you're going to solve for the unknown, and then you always need to make sure that you check your work to make sure your solutions actually do hold true for the original absolute value. So here's an example. We've got the absolute value of 4x equals 24. So here our absolute value is already isolated. So we're going to break this into two separate options. We can have that that 4x is equal to positive 24, or it could be true that that 4x is equal to negative 24. So working with the positive 24 first, we have dividing both sides by 4. We get that x could equal 6. We also have that 4x could equal negative 24, so dividing both sides by 4. We get another solution that x equals negative 6. So remember always to check your work. So when x equals 6, plugging that into the original equation, we have that the absolute value of 4 times 6 equals positive 24, which absolute value 4 times 6 is 24. So the absolute value of 24 is 24, and check that is true. Now our other solution was that x was negative 6. So the absolute value of 4 times negative 6, we want to see if that is also equal to positive 24. Well, 4 times negative 6 is just negative 24, and we know the absolute value of negative 24 is also going to be positive 24, since negative 24 is 24 units from the origin. So the next example is the absolute value of 6 minus 3x equals 9. And so here again our absolute value is already isolated on the left side of the equation. So again, we're going to break it down into two possible situations. One where 6 minus 3x is equal to 9, and another solution where 6 minus 3x is equal to negative 9. So having it equal to 9, subtract 6 from both sides to get this x by itself. Negative 3x is then equal to positive 3, and this, now divide both sides by negative 3, and we get that x could equal negative 1. Or our other solution would give us that, again, subtract 6 from both sides, negative 3x, but negative 9 minus 6 is going to give me negative 15. Divide both sides by negative 3. and we get that x is going to equal positive 5. So we have two possible solutions, x equals negative 1 or x equals positive 5. Again, it's always important to double check your work. So if x equals negative 1, plugging that into the original equation, 6 minus 3 times negative 1. We want to check to see if that equals 9. So that's the absolute value of 6 minus 3 and times negative 1 is going to give me a positive 3, which is going to give me the absolute value of 9 equals 9, which is indeed true. My other solution was x equals 5, so same thing, 6 minus 3 times 5. We want to see if that also equals 9. So that's going to be the absolute value of 6. Negative 3 times 5 is going to be minus 15. And we want to see if that also equals 9. And here we go. We've got the absolute value of negative 9 equals 9, which again we know is true. It's also important to know another way you may see the solution. So this is one way where you see the x equals negative 1 or x equals 5. You also might see it written with the little squiggly brackets and the solutions written inside of them. These mean the same thing. These are both correct solutions. So you could either see it either of these two ways. All right, my third example, as you immediately see, my absolute value is not isolated. So that's going to be my first step, is going to be to do some algebra to get that isolated. So let's go ahead and subtract 10 from both sides. I'm left with 5, absolute value of 1 minus 4x. These become 0, equals positive 5. Divide both sides by 5. And I'm left with the absolute value of 1 minus 4x equals 1. Now that I've isolated the absolute value, I know I have two different solutions. One could be that 1 minus 4x equals positive 1, and the other is 1 minus 4x could equal negative 1. So if 1 minus 4x equals positive 1, then I can subtract 1 from both sides. That gives me negative 4x equals 0. Divide both sides by negative 4, and I get one solution that x could equal 0. My other solution, again, subtract 1 from both sides. I get that negative 4x equals negative 2. Divide both sides by negative 4. And I'm left with x could also equal positive 1/2. Before we move on, remember it's important to double check your work. So our two solutions were either x equals 0 or x equals 1/2. So plugging that into our original equation, let's see, if x equals 0, then we'd have 5 times the absolute value of 1 minus 4 times 0 plus 10 equals 15. So that would be 5 times the absolute value of 1 minus 4 times 0, which is just 0, plus 10 equals 15. This is 5 times the absolute value of 1, which is just times 1, plus 10 equals 15. And yes, 5 plus 10 does equal 15. So that solution does work. The other solution was that x equals 1/2. So again, if x equals 1/2, let's go to our original equation. So we had 5, absolute value 1 minus 4 times 1/2 plus 10. We want to see if that indeed equals 15. So that's 5, absolute value of 1, negative 4 times 1/2 is going to be minus 2. Oh, and that's missing up there. Plus 10 equals 15. Subtract 10 from both sides. Oh, actually, hold on, let's just not even do that. So here we've got the 5 absolute value. 1 minus 2 is negative 1, plus 10 equals 15. And the absolute value of negative 1 is going to be positive 1, plus 10 equals 15. And yes, we have 5 times 1 plus 10 does equal 15. And again, we could write that solution either as x equals 0 or x equals 1/2, or you could also write it as 0, 1/2 in the little squiggly brackets. Alright, the last example is the absolute value of 3x plus 7 equals negative 2. Immediately, some of you may be wondering what's going on here. So I immediately notice we have that the absolute value equals a negative, but we know that the absolute value is always the distance from the origin, therefore the absolute value must always be positive. But let's act as if we didn't notice that. So let's say we noticed, okay, we've got the absolute value isolated on the left side, and then my next step is to set what's inside the absolute value, 3x plus 7. We want to have it equal to the positive and have it equal to the negative. So if I went ahead and worked through this, subtracted 7 from both sides, be left with 3x equals negative 5, divide by 3. I'd have that one possible solution would be that x equals negative 5/3. On the other side, I had subtracting 7 from both sides, 3x equals negative 9, divide both sides by 3, and I'd have another possible solution that x equals negative 3. But checking your work, and this is why checking your work is so important, the absolute value of 3 times negative 5/3 plus 7, I'm going to see if that equals negative 2. Right here, these 3's cancel out. I'm going to have the absolute value of negative 5 plus 7 equals negative 2. And that leaves me with the absolute value of positive 2 equals negative 2, which is not true. Okay, so that solution did not work. And similarly, over here, if I plug in this negative 3 for my x in the original equation, so into the absolute value of 3 times negative 3 plus 7, I'm going to see if that equals negative 2. And again, we'd have the absolute value of negative 9 plus 7 equaling negative 2. And here we'd end up with the absolute value of negative 2 equals negative 2, which again we know is not true. So how we would write the answer to this, which many of us, may have noticed right there at the beginning, is you would say that this has no solution. You can write that as a little circle with a line through it, or you can just write out no solution. Okay, so this is the end of the 1.6 notes for absolute value equations. Remember to go through your notes. Your notes must be handwritten. They can't be copies or screenshots of the work done here. It actually has to be handwritten notes within your composition notebook. Go ahead and go into My Math Lab, work through those examples for section 1.6, and come to class with questions. And and I guess that's it. Yes, we will see you in class.